Now we work with polar. So polar is not xy anymore, is r theta. Something that was covered back in pre-calculus. So this is, again, rectangular or Cartesian coordinate. And this is the polar coordinate. So what's the relation between them? Well, we know that x equals r cosine theta. So if you draw a right triangle with x and y and r and theta. So x is r cosine theta, y is r sine theta. And we have x squared plus y squared equals r squared. Also, the y over x is tan theta. So these are the relations between the polar and rectangular coordinates. We first try to recall how to plot points in polar. Let's call point A with 3, 45, because all the points are going to be in the form r theta. So all of them are r theta. So r is 3 and theta 45. So the way this works, you start with the angle 45. So this is a 45-degree angle. When you draw the line, think about it, that's the new x-axis, the new positive x-axis. So 3, you're going to go 1, 2, 3. That's where point A is located. If they give us a point B, let's say 45, comma, negative 3. Sorry, negative 3, comma, 45. So then the way it works, again, you start with 45, that's 45, the one we drew earlier, and then negative 3. So this axis, again, it's like the positive x-axis. Think about it this way. So its negative would be the other side. So you would go the other side 3 steps, and that's where B is located. How about if we change it to negative 3, comma, negative 45? Both of them are negative. So I'm going to plot this point. First, I start with the negative 45 degrees. So now, when I drew this, that's like the positive x-axis. So, but they said negative 3, so you're going to go the other side, the other direction, that's T. Try to graph this one, E6, comma, negative pi. First, we start with the angle negative pi. Remember, that's always positive direction, that's negative. So negative pi, that's a negative pi. And now this is my new, like, positive x-axis. And then 6. So you're going to go 1, 2, 3, 4, 5, 6. How do we convert from, let's say, polar to rectangular, or vice versa? Let's say this one, 4, comma, 2 pi over 3. You can tell this is polar. It's like r theta. So how are we going to convert that? I want to find the x, y coordinates. What's the x here? X, we defined it at the beginning of today's lesson as r cosine theta. R is 4, cosine 2 pi over 3. Cosine 2 pi over 3 is negative 1/2. So it's negative 2. and the y is r sine theta. R is 4 sine 2 pi over 3. Sine 2 pi over 3 is root 3 over 2. 2 square root of 3. So convert negative 1, 1 into polar. So to convert this one, they give us x and y. We need r and theta. Remember, r is the square root of x squared plus y squared. X is negative 1. Y is 1. So that gives me square root of 2. Now for theta, to find what theta is, we know theta is tan inverse of y over x. So theta is tan inverse of negative 1 over 1, or 1 over negative 1, which is negative 1. So now how do I find the angle? This is what I do to find the angle. 1, negative 1, it's there. That's the point. You connect the pole here to that point. And this is the angle I'm looking for. So if you happen to cover the negative sign, what's tan inverse of 1 is 45. Right? 45, or pi over 4 on this side. So that would be the 2 pi minus pi over 4, which is 7 pi over 4. What do you think? Now when you do this, oh wait, it's not negative 1, 1. It's negative 1, 1, not the 1 negative. So we plotted the point in the wrong quadrant. Wait. It should be negative 1, 1. I always double check it after I plot the point. So negative 1, 1 here. So this is theta. If the angle is, again, if you pretend there's no negative, like 45, that would be here. That would be there. This is the pi over 4. So then the angle I'm looking for, theta, is going to be the pi minus pi over 4. That gives me 3 pi over 4. So I found r and theta. So r is square root of 2 and theta 3 pi over 4. So that point, negative 1, 1, is equivalent to square root of 2 comma 3 pi over 4 in polar. Since we were working on the other one that I put in the other quadrant, let's do it. 1, negative 1. So another example, we would like you to write it as r comma theta. First, we find r, which is the square root of 1 square plus negative 1 square. So r is the square root of 2. Then we need to find theta. Theta is tan inverse, again, of negative 1. To find the angle, the easiest way is to plot the point 1 comma negative 1. So the angle always starts with there and goes all the way to the terminal side, theta. Yeah. So here, if there's no negative 1 like positive 1, that would be 45 or pi over 4. So the 2 pi minus pi over 4, that will give us 7 pi over 4. So the answer becomes r is the square root of 2 and the angle 7 pi over 4. Or someone asked, can I do the negative stuff? Yes, you can put the angle negative pi over 4 and then square root of 2. You can go from the other direction down and then square root of 2. Either answer is fine. How about if we are asked to convert an equation like this into rectangular? expression like this into polar. You multiply both sides by r. R squared is r sine theta. Why did I do this? Because now r squared is x squared plus y squared, and r sine theta is y. Next one, r squared, x squared plus y squared is r squared. How about xy? X is r what? Cosine theta, and y is r sine theta. See, no more x and y. If you want to simplify, this is r to the fourth, r squared cosine theta, sine theta. You could divide by r squared both sides, and that's what you get, cosine theta, sine theta. So that was basically a quick review from pre-calc about revision of how to convert from polar to rectangle if it's an equation or a point, and how you plot polar points. Now we move on to polar curves. We're going to look at several graphs for the polar. The first graph if you are given r equal constant, like r equal 2 or r equals 3, how is this going to look like? Okay, so A is constant. So what happened here is, let's say you're graphing r equals 2. What is theta? Well, theta could be anything, 0, 1, 2, 3, 200, 250, 360. So every time you're graphing 2, you're going a different angle. That will give us, so let's say you want to graph angle 30 with distance A, 40, 60, 90. See, look, it's the same. So when you connect them, you got this circle. You got a circle. Circle with radius A. Circle with radius A. So theta is any. It could be any measurement. So always r equals a number. You will get a circle. That's the first one. The second one, how about if theta is constant? Let's say c. In this case, r is any. R is any. So let's say like they give us theta pi over 4. How do I graph this? You graph the pi over 4. This is pi over 4. R could be 1, could be 2, could be 3, 4, 5. It could be a negative even. Negative 1, negative 2, negative 3, negative 2.5. Who cares? So then this tells me every time you have theta equals number, you're going to get a straight line. Now, R equals A sine theta. How does the graph look like? Well, this is how it looks, and we can prove to you why that's the case. There are two cases depending on A, if A is positive or negative. If A positive is going to be a circle in the upper half plane with radius, with diameter A. That's if A positive. If A negative, it will be another circle but in the lower half plane with diameter A. So sine always either up or down. For cosine, it's going to be right or left, depending on A again. If A positive will be a circle in the right plane. If A negative will be a circle in the left plane. So this is when A positive. This is when A negative. All of this was covered in pre-calc. We're just reviewing this stuff. Now, there's many ways to graph this, not just, but it's best to know that if A is sine, it's going to go on the top, upper half plane. Otherwise, in pre-calc, we start teaching them why is it a circle, using two different things. We construct a table of values. We take R, get the thetas, and then, or take theta, find the R's, and then we plot the points, and then when we connect them, we get a circle. Another way is we convert the R equals A sine theta. Let's say R equals sine theta or 2 sine theta by multiplying both sides by R as we did earlier, and we convert to, we get x squared plus y squared equals something, and then we complete the square on that to get a circle. You know? But we're not here at this level to test the students if you can graph it or not. We need to learn something related to calculus here. So that's why these things not needed. We can move on to a different version of graphing that we need to know. It's good to know. It helps a lot to save time. If R equals A plus or minus B, let's start with sine theta. First case, let me use this as a first case like that. First case when A and B are the same. When A and B are the same. When A and B are the same and you have a positive case, say R equals A plus B and both are positive, then we are going to get something like this, upside down heart. It's called cardioid. If A equals B, but it's minus, is going to actually look like a heart. So that's called cardioid. How about if R is A plus or minus B cosine? Well, if you get the sine, you can get the cosine. Still cardioid, but the direction of the heart is different. So it's going to be to the right this way, or it's going to be to the other side this way. That's when it's R is A plus B, both are positive, assuming, and that's when it's negative. Now, let's say I want to talk about R equals 2 plus 2 sine theta. Okay, so we know it's a cardioid because A and B are the same. We know it's positive and sine, so it's going to be in the upper half plane. So when we graph this, we know it's going to go like this. So if you see, because these are the same, A equals B equals 2, this means you go 2 on this side and 2 on that side, 2 units to the right, 2 units to the left. And then up there you just add A plus B, which is 4. That's what that number is, assuming the two are the same, A and B are the same. So if you're asked 3 plus 3 sine, you go 3 to the right, 3 to the left, and 6 up. If they ask you R equals 3 minus 3 sine, you're going to still go 3 to the right, 3 to the left, and 6 down. So, it's in the upper. That's a minus, so it's going to go down. So 3 this way, 3 that way, and 6 down, if you want to put negative 6 or 6. So you don't have to, this helps a lot because you don't have to sit down and write them one at a time. Now, same scenario works for other ones. Like if A less than B, for the same equation, r equals a plus or minus b sine, or r equals a plus or minus b cosine theta. In these two cases, we call it limison with inner loop. Limison with inner loop. And for one case, for example, you know how we drew the heart, looks like this, but then there's an inner loop in there. Same scenario works. That's if the case a less than b. So this would be for a plus b sine theta. Assume again both are positive and a bigger than b, a less than b. I will pass a handout, like a summary chart that shows you every time you see a graph, this looks like this form. It's much easier. Yes. So what do we have in here? First, we're going to learn how to find the slope of the tangent line. So we can say tangents to polar curves. Tangents to polar curves. All the polar functions are going to be written in terms or in the form r equals f of theta. Or some people write r of theta. It's fine. Keep in mind x, we told you x is r cosine theta. Or you can write it f of theta cosine theta. And y is r sine theta. So y, r is f of theta sine theta. So we have x and y. The question is how to find the slope of the tangent line, which we used to call it dy dx at some point. We can rewrite this as dy d theta over dx d theta. So basically they're asking, find the derivative of y with respect to theta. You can find it here using product rule, right? You can find it using product rule. So it's f of theta times the derivative of sinus cosine plus derivative of f, which is f prime of theta, times sine. See, I use product rule on y. We do the same thing for x. So f of theta times negative sine theta plus f prime of theta cosine theta. So this is the formula to find the slope of the tangent line to a polar curve. To apply that, we are going to determine the equation of the tangent line to the graph of f of theta is 3 plus 8 sine theta at theta pi over 6. So first we need to find the slope, dy dx. We give you the formula. F of theta is the 3 plus 8 sine theta times cosine theta plus f prime, which is 8 cosine theta times sine theta over negative the function itself times sine theta plus the derivative, which is 8 cosine theta times cosine theta. Straightforward. At theta equals pi over 6, we substitute that in, so dy dx at theta equals pi over 6 is going to be 3 plus 8 sine pi over 6 times cosine pi over 6 plus 8 cosine pi over 6 times sine pi over 6, all divided by negative 3 plus plus 8 sine pi over 6 times sine pi over 6, 8 cosine pi over 6 times cosine pi over 6. And we have to calculate all of this, which I'm assuming everyone can do that. And we got the slope. You know, sine pi over 6 is 1/2. Cosine pi over 6 is square root of 3 over 2. If you simplify the numbers, it goes down, or simplifies down to 11 square root of 3 over 2 over 5. The slope, and remember the equation of the line, y minus y1 equals m times x minus x1. So this is m for the tangent line. I'm missing x and y, so I need to find x and y. Remember, x is r cosine theta, r or f of theta. So f of theta was 3 plus 8 sine theta cosine theta. So then we can evaluate the x at pi over 6. Sine pi over 6 cosine pi over 6. And then, if you simplify, you get 7 root 3 over 2. That's for x. Similarly for y, r sine theta. R is 3 plus 8 sine theta times sine theta. If you substitute pi over 6, so you're going to get 3 plus 8 sine pi over 6 times sine pi over 6. And this simplifies to 7/2. So now we have a point 7 square root of 3 over 2 comma 7/2. And the slope of the tangent line 11 root 3 over 5. From here you can use y minus y1, the slope times x minus x1. And you don't have to simplify more. This is more than enough. Now we can look at another example. The slope. Here they're asking only to find the slope, not the equation. Find the slope of the tangent line to the polar curve r equals f of theta 1 plus 2 cosine theta at theta pi over 3. So again, to find dy dx, it's the formula I gave you. It was f of theta cosine theta plus f prime of theta sine theta divided by negative f of theta sine theta plus f of theta cosine theta. So for this one you get 1 plus 2 cosine theta, all that multiplied by cosine theta, plus the derivative is negative 2 sine theta times the other sine theta over negative 1 plus 2 cosine theta times sine theta plus 1 plus 2 cosine theta times cosine theta. Dy dx, theta equals pi over 3. If you substitute all that in, the answer should be root 3 over 9. Square root of 3 over 9. So there's a derivative there. So if you plug the value in, you should have gotten this answer, √3/9. So the problem here is a lot of students, they used to use calculus to find sine and cosine. That's why they stuck at this last step. So you must find sine and cosine, or you know the unit circle. You must know it. And then after you substitute the values in, you must simplify the fractions. You must simplify it all the way to this point.